Hey, welcome back. Today we're going to be talking through the electric force. So this is not the conceptual version of it. This is building on that conceptual version of the electric force in a mathematical sense. In fact, I'm going to show you exactly what you need to know to be able to use this equation effectively, and something that's very special about this equation, as well as how to type this into a calculator effectively and not make a mistake. So let's go ahead and get to it. First of all, there are two different examples shown of Coulomb's law, where you've got a Kc, this is Coulomb's constants, and basically both equations are going to be exactly the same. It's just how it's presented looks slightly different. In fact, you're going to multiply Kc times Q1 times Q2 in both equations. So both of them have a numerator of that value and then divided by r squared. Q1 is going to be the amount of charge on the first object or particle. Q2 is going to be the amount of charge on the second object or particle, and r represents the distance in between the two objects, and of course that's going to be squared. So we can start the problem and just write out the equation. So F electric is equal to Kc times Q1 times Q2 over r squared. So that's our equation, and if we read the problem right here, it says what is the force between a strand of hair and a balloon when the charge in the balloon is this value, and the other value is going to be a -7. I forgot to type that in, but it is what it is. Since the same amount of the electrons were rubbed off the hair and onto the balloon, and the distance between the balloon and the hair is 3 centimeters. One thing that stands out in my mind is we're going to need to convert this over to meters, and so we might as well do that now and be careful with that. And it's time. It's really that easy. If we think about it, we're looking for this. We know what our Kc is, we know what our Q1 is, we know what our Q2 is, we know what our R is. So we can go ahead and just plug in our numbers. So I'm going to show you how to do that and something special about this equation as well. Alright, so this is how you would set up the equation and what it would look like, but let me drag this up here. I also really think it's important for students to know, what do I put into my calculator? Sometimes students literally don't know how to type this into a calculator, so I want to talk you through that as well. So the first thing we want to do is use actually two sets of parentheses. The first one is going to represent our numerator. The second one here is just for anything that's in scientific notation. Scientific notation is where you have some base number times 10 to the something power. That's what we mean by scientific notation. So whenever you have that, you're going to go ahead and do this kind of thing here. You probably have a button on your calculator that looks like this, or maybe it has an EE button, or maybe you have a button that looks like times 10 to the something power, or maybe you don't. Maybe you just have to literally type in times 10 to the, and then you tell it what the power is. In this case, to the 9th power, right? So we're going to assume that you can find a button like that on your calculator or come up with the alternative. The next set of parentheses needs to have this value in here, right? And notice I'm going to go ahead and close up that original set of parentheses. So I have an extra set of parentheses around anything that's in the numerator. And over here, I'm going to write this in. And then I'm just going to hit enter or equals or whatever your final button is on your calculator. So notice this whole thing is going to represent the numerator, and this thing over here in these parentheses is going to represent the denominator. So just be careful with that, but notice the extra set of parentheses that'll help us to do the numerator, and then parentheses around anything that has scientific notation with it. So if you set this up correctly, I ended up with this as my answer. And we need to talk about that as well, because we end up with a negative answer with that. That's because you have one negative sign right here and one positive sign, and then everything else is positive. And so we need to think about, what does a negative sign mean for this equation? Well, that would mean you would have one positive Q1 and one negative Q2, so to speak, or vice versa. The order doesn't matter in this case so much. In that case, you would end up with attractive forces. So it's really important to notice that if we run Coulomb's law, and we get a negative answer. Think about what that means. That means you have one Q value that's negative, one's positive, and opposite charges are going to attract each other. Let's think about what would happen if you had two positive charges and you ran this. If you had two positive charges and you ran this, you would get a positive answer. The answer you get out of Coulomb's law represents the amount of force that you could say this is the force on Q1 from 2 and this is the force on Q2 from 1. They're equal and opposite to each other. So you've solved for that value, but that also means that they are going to be repulsive. In other words, they will repel each other. So a positive answer signifies repulsive forces. All right, and let's think about why that would be. Again, if you had two negative charges, then they would repel each other as well. You run it through Coulomb's law, you would end up with a positive answer as well, because if you multiply a negative number times another negative number, you end up with a positive result. So that's really crucial about Coulomb's law. When you get a positive or negative result, what it really means is whether or not you're dealing with attractive or repulsive forces. So it's super important to recognize that. In any case, hopefully this has been helpful. If you have any questions or comments down below, please let me know. And I've done physics lessons for an entire year of physics and many AP Physics C Mechanics lessons as well. Take care. Hope you have a great day.